So group 17 includes the halogens. Halo means salt and gene means producer. So generally most of the salts are in the form of chlorides, bromides, right? So if you look at most of the salts like sodium chloride, potassium bromide, so halide ions are involved. So since most of the salts are in the form of halide ions, so they are generally called as halogens. Now halogens include fluorine, chlorine, bromine, iodine, astatine. Now astatine is radioactive, so it is studied separately with the rest of the radioactive elements. So we'll be focusing on the first four, that is fluorine, chlorine, bromine and iodine. Okay. Now what is specific about the halogens is that their general outer shell configuration is Ns2np5. So only one electron less than the noble gas configuration. So they have a very high tendency of gaining one electron, because by gaining one electron, they acquire the noble gas configuration. So just one electron less than the noble gas configuration. Right? Now let's study the physical properties. So if you look at the atomic and the ionic radii, so there is no exception as such. Atomic and ionic radii. So as the shell increases, third, fourth, fifth, sixth, these corresponds to these respective periods. Second period, third period, fourth, fifth and sixth. And each period corresponds to particular shell. So the outermost shell configuration for fluorine is 2s2, 2p5, 3s2, 3p5. Okay? Likewise for bromine, 4s2, 3d10, 4p5. Iodine, 5s2, 4d10, 5p5. So the outermost shell configuration is Ns2np5, as we just discussed. So as we move down the group, because of the addition of shells, the atomic radii increases. So down the group, atomic radii as well as their ionic radii. Okay? Generally they are present in the form of halide ions. So fluoride, chloride, bromide, iodide, there's a regular increase in the ionic as well as the atomic radii. So down the group, atomic radii increases as well as their ionic radii also increases. So the usual reason that we give, there is addition of shells. Okay, shells are increasing. So because of the addition of shells, the atomic and the ionic radii increases. Alright. Now what is the next? Let's see the next property. Then next is ionization enthalpy. Second is ionization enthalpy. How do we define that? Ionization enthalpy is the minimum energy required to remove the outermost shell electron. So because see in the respective period, if you see their sizes, तो क्या हो रहा है, along the period जो होता है size decrease करता है. तो noble gases से पहले ये है, noble gases के generally sizes बड़े होते हैं because of the van der Waals radii. So these halogens are the smallest in the respective periods, right? So you can remember like this: halogens are the smallest. Halogens are the smallest in respective periods, because along the period the radii decreases. Right? Now because they are small in size, their ionization enthalpy is expected to be very high. Okay? So when you compare ionization enthalpy, so naturally if you compare them with the other metals, so the ones which have larger radii, उस केस में क्या होगा? न्यूक्लियस एंड इलेक्ट्रॉन के बीच में डिस्टेंस ज्यादा होगा. अगर डिस्टेंस ज्यादा है, force of attraction is poor and it is easier to remove an electron. But if the size is small, then the distance between nucleus and the outermost shell electron is less. Now, if the distance is less, there will be a strong force of attraction from the nucleus, and it will be difficult to remove the outermost shell electron. So, because of smaller atomic radii, their ionization enthalpies are high. Their IE values are high. And what is the reason? Small atomic radii, small size of their atoms, small atomic radii and high effective nuclear charge. Because of the small size, the nuclear charge acting on the outermost electron will be very high. So small atomic radii and high effective nuclear charge. So ionization enthalpies are quite high. Okay, and down the group. What is the trend down the group? This is in the period. Okay, generally their ionization enthalpies are very high. Now because their ionization enthalpies are high, they will have a very less tendency to lose electron. Okay, so generally they do not lose electron because of the high ionization energies. Now let's see the trend down the group. What will happen down the group? Down the group, as the size increases, it will be easier to remove an electron. So as the size increases, force of attraction between the nucleus and electron will decrease. So down the group, ionization enthalpies decrease gradually. Okay, so iodine के case में we hear iodonium ion, I positive ion formation is there. So because down the group there is IE decrease कर रहा है, so it will be like possible to remove an electron from the outermost shell. Generally the halogens, they have the other tendency, the tendency to gain. Okay, so generally they do not form positive ions, but in few cases iodine has been reported to form I positive. Right? So down the group, because ionization energy is decreasing. And what is the reason? Because of the increase in size. So as the size increases, ionization energy decreases. Atomic radii increases down the group. Therefore, ionization energy decreases. Okay, now the third property is electron affinity, or in terms of energy we call it as electron gain enthalpy. Electron affinity, or we call it as electron gain enthalpy. See, affinity means attraction. So electron affinity means attraction for the electron. So because now they have in their respective periods they have small sizes. ठीक है, एक particular period में जो halogens है वो सबसे smallest है, तो क्या हो जाएगा, जो incoming electron है और nucleus है उसके बीच में distance कम है. Because of the small size, the distance between the incoming electron and nucleus is less, so there is a strong force of attraction. So an electron is easily pulled inside the shell, the outermost shell. So what is electron affinity? Attraction for the incoming electron. And when the electron is added to an isolated gaseous atom, if in terms of energy we talk, so there's this isolated gaseous atom, electron is being added, और क्या बन रहा है? Negative ion. So जो energy change होगा during the process, that is called as electron gain enthalpy. So in terms of energy, हम क्या बोलेंगे? Electron gain enthalpy. ठीक है? So what is electron gain enthalpy? It is the energy change when an electron is added to an isolated gaseous atom. So जब electron add हो रहा है atom में, तो जो भी energy हो रहा है, change हो रहा है. So generally, if the force of attraction is strong, if attraction for electron is strong, electron is easily added. So we will say the electron affinity is high because of the small sizes. They have high electron affinities. ठीक है? and generally when the force of attraction is strong, more energy is released. So they have high negative values of electron gain enthalpy. ठीक है, तो जब हम बोल रहे हैं high electron affinity, see halogens have, first point is they have high electron affinity. High electron affinity. So high electron affinity means because of the small size, they have a very strong attraction for the incoming electron. So attraction for the electron is high. Now because the attraction for the electron is high, electron is coming closer to the nucleus. Now when electron comes closer to the nucleus, energy is released in the process. So delta H has negative value. So we can say halogens have high negative electron gain enthalpy. So when we talk in terms of enthalpy, then you have to remember negative sign. They have high negative electron gain enthalpies. And in terms of electron affinity, they have high electron affinity. Okay, so when you compare with the rest of the period elements, because they have smaller sizes, so they have a very high tendency to gain electrons. Now let's compare down the group. So when we compare the trend down the group, so what is the order down the group? Which has the highest electron gain enthalpy? Although fluorine, because of the small size, is expected to have a high electron gain enthalpy, but क्या होता है? Fluorine में inter-electronic repulsions are high, so because of that, the tendency to gain is little less than chlorine. So the order of electron gain enthalpy is chlorine has the highest, then fluorine, then bromine, then iodine. ठीक है, तो फ्लोरीन कहाँ होना चाहिए था? सबसे पहले, लेकिन as an exception fluorine is present after chlorine. So remember it as an exception. Electron gain enthalpy of fluorine is less than chlorine. Now what is the reason? The reason is due to small size of 2p orbital. We're talking about fluorine, right? So small size of 2p orbital in fluorine, there are strong inter-electronic repulsions. ठीक है, अब ये जो 2p का ऑर्बिटल होता है ये स्मॉल साइज का है. So because of the smaller size, the electrons are very close together. Electron density is high, and because of the closeness of electrons, electron density high है, so inter-electronic repulsions will be there. And because of these inter-electronic repulsions, the electron will not be added easily. ठीक है, जो भी इलेक्ट्रॉन ऐड हो रहा है शेल में उसको रिपल्शंस फेस करना पड़ेगा, so easily ऐड नहीं होगा. Right? So due to small size of 2p orbital, there are strong inter-electronic repulsions. So addition of electron is less favorable. Right? As compared to chlorine, इतना भी less favorable नहीं है कि वो ऐड ही नहीं होगा. We are just comparing it with chlorine. Chlorine में 3p orbital में addition होना है और fluorine में 2p orbital में. 2p का size छोटा है, electron density will be high. There will be inter-electronic repulsions. So due to that, it is like easier to add in chlorine as compared to fluorine. So remember, the electron gain enthalpy of fluorine is less than chlorine. ठीक है, तो repulsions होती है, तो जो incoming electron है, it will not experience attraction. ज्यादा attractive force नहीं होगा क्योंकि repulsions भी strong है. So incoming electron will experience less attractive force, so addition will not be so much favorable. Then the next important property is electronegativity. Now electronegativity has no exception. Exception किस में था? Electron gain enthalpy में. Electronegativity कैसे define करते हैं? Tendency, it's a relative tendency. Tendency to attract shared electron pair towards itself. The next property is electronegativity. Generally, the symbol used is chi. So it is the tendency to attract the shared electron pair towards a particular atom. So out of the two atoms, the one which attracts the shared electron pair more is said to be more electronegative.